Hello everybody, welcome back to From Rhythm to Algorithm Part 8, Strings and Things. I just saw a couple different, just a lot of math things and physics things and linguistics things I want to talk about today. But the place I want to talk about string theory as is. What is string theory, right? String theory is the terminology for theoretical physics attempt at grand unification. Grand unification. And so let's start with the motivations of physics. The point of physics is to build a mathematical model to improve technology. Not to perform a bunch of mental masturbation. Grand unification. And so there's a couple just nuanced things. People will talk about the theory of everything. The theory of everything doesn't really exist. That is a weird expectation that the society has formed in scientific research. Grand unification, the logical verbiage, sounds pretty good. And that is what I have done. I have showed there's a logical basis of mathematics that is rooted in language, and it is unavoidable to literally speak or structure. Literally, you don't even need to structure a sentence, you can just make sounds. You are going to demonstrate the fundamental basis of logic. But is that the theory of everything? Kind of. The theory of everything to me implies the word everything means literally describes everything. Everything hasn't happened yet. So what you have to do, just the same in any mathematical class right now today, from kindergarten to graduate level or independent research, you talk about basis and range. We have shown the basis, and we have shown how that covers and touches every ontology of scientific research. So that really does achieve what I think is meant by grand unification. I don't really like the verbiage, just again, logical nuances, but the search for the theory of everything. And again, we've said it multiple times, but they're not theories of everything. But past that, there's some math I wanted to talk about. Some of this is going to be spotty because again, I literally do mathematics 10 hours a day. Most of my research, actual fundamental logic, is not in these lecture series. But these are complete. Like these, you are not missing any of the core ideas or any of the meat of what of the research I've done. But there's something that I've called the basis of agreement, and I want to talk about the historical reference to 12. Right, you have 12 tribes of Israel. You have 12 Greek people in this thing. You have 12 appears everywhere, and I don't know why. The mathematical basis, the proper physically implied natural number system is base 2. The reference to 12 is, I want you to imagine you're a human being on a rock and you wanted to say any logical statement to another person and see if they agree with you. What is the simplest way you could say that? And there's a correct answer to this. I'm not going to try to explain this much because this is the basis of I can explain the basis of physics. You can go experiment with that. You can go toy around. You can show people physical experiments. This is the basis of logic, and it's really, I mean, most open math problems are well outside of known mathematical capacity. This is outside of like societal expectation for logic. But I think 2 and 3 exists because we agree. Is the simplest representation of language that you could produce to have the idea to say, I am going to validate a measurement to another person. I think 2, and remember, we should be able to show profound historical analogs. I think, therefore I am. I think is the first thought anyone has. I think 2 and 3 exist because we agree. Because we agree. Simply saying, logically saying, if I measure the spin of an electron up and Johnny measures the spin of an electron up because we both got the same measurement, or because we both observe the same thing, that's why it exists as it does. But count those syllables. I think 2 and 3 exist because we agree. 12 syllables. That is the simplest string of syllables to produce the basis of agreement to demonstrate a valid measurement. Can't say it any other way. The end. But this is why there is a historical reference to 12 everywhere. The interesting thing to me is why is there a better why are there even fractions for dividing 12 when 12 and 10 are both, as opposed to a base 10 number system when 12 and 10 are both even numbers? I don't know. I personally do not know that. But that's, and so another just nuance, anytime anyone is saying the word dimension, there are 3 dimensions. There are a multiplicity of directionality. Dimensionality is always 3. Nothing has ever existed that can ever speak, ever think, ever be sentient to any way that hasn't been in 3 dimensions. You can't think in more than that, it doesn't even make any sense. Stop it. But directionality, there's a multiplicity to it, right? 12, simply 12 divided by 2 is 6. In string theory, you have 60 symbols. And all of this and the Collatz conjecture, I'm going to start over my camera to make sure I have enough time, but this is all from what I have called the fundamental stability of 2. So let's talk about that now. So jumping right back in, the fundamental stability of 2, like I said, there's 2 directional components needed to describe radiation and radiation, vibration, and then there was light, wink wink, and then there was matter and mass. So just I can't solve the Collatz conjecture today, but I'm intimately aware of the structure of the proof. So I'm just going to kind of riff openly, just talk about what like I said, what's interesting to me and what I know for sure, why I think things are coming from where, blah blah blah. But that's physically what the fundamental stability of 2 is. And if you were to say, like I said, Brad, define it mathematically, write the definition up here and the implications, I can't. Like I said, this is what I'm trying to figure out now mathematically. But the statement of the Collatz conjecture is this. Start with any integer n as an element of the real numbers. Now, in natural mathematics, and again in my formal paper, I've simply asserted, but it's absolutely true, there's no need for irrational numbers at all. And had intimate relations for the solution or progressing the measurement problem of quantum mechanics, but in complete generality, for whatever reason, because 2 and 3 in pairs and something, there's no need for irrational numbers. But you take n, this is just all known, accepted mathematics, n as an element of the reals. You take that n, you can start with any number that's like above 0, but you could take I'm sure there's an analog for just the absolute value statement of the problem as well. But take n divided by 2, if n, and then you take, if n is defined as 0, I don't really get what that's saying, or 3n, you take n times by 3 and add 1, if n is defined as 1, mod 2, there's the modularity. I might even mess this up, but if you have some n, the mod, and it's your mod 2, you're dividing it by 2 and there's no remainder, and the modularity is however many times it's been equally divided. And there's just no remainder. But again, the prevalence of modularity in mathematical calculations at all is again evidence of what I'm saying is there's no natural reason to have an irrational number. And then they generalize it here, and I wanted to just show just people who state mathematical problems, researchers. To me, this is just redundant. Like, there's no point to do this. A defined as I integrated I times n for all I equals 0. So that just says if I put 0, A naught is n. That doesn't, it's just redundant. There's no point to do that. This generalization doesn't do anything. And then you just say, you apply this function for anything that isn't 0. Just trivial, moving on. But the reason and if you apply this function however many times or to infinity, you'll arrive at 1. And again, the reason is because this is some numerical, has direct analogs, right? If you, to the same other, like if you ever heard there's a common, if you take some n number and there's some algorithm, you times it by 3, divide by 2, blah, 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 you come back to, well, I guess that's when I learned it. I didn't learn it in math class. But the point is what you're doing is you are rooting a number system. And when we proved the Riemann hypothesis, we described why physical objects interacting, why the concept of rooting in mathematics is directly mapping or graphing the intersection or the collision points of physical objects. So this is just another numerical manifestation of that. And like I said, that's the structure of the proof. And I said this isn't the proof because I personally think I can, there's something I'm staring at directly that I can prove or make a more definitive statement or just provide more insight. But the thing I wanted to point out in this video is string theory. We've talked about ontologies as well. The natural ontology, why is string theory existent at the species level, is because the natural ontology for string theory is linguistics. A string of syllables is a word, a string of words is a sentence. And the other thing I wanted to say is, again, I don't know what I'm trying to say, but the fundamental stability of 2 will have a direct linguistical analog to the progression of verbs. How many conjugated verbs come in a row? I don't think it's ever 2. Like 2 unconjugated verbs sequentially, one's ing and one's not ing. Something like that, I don't know. I'm staring at the answer, I can't say it. But thanks for watching Strings and Things, and check back for more.